Hello, I'm Isabel with High Tech Design Safety, here to guide you through semiconductor laser safety beyond compliance. At HTDS, we specialize in semiconductor process equipment and industrial machinery evaluations with over 1,400 successful projects completed across a wide range of industries. Today, we are discussing an important topic that continues to grow alongside semiconductor manufacturing technology: laser safety. When most people think about laser safety, they immediately think about warning labels, eye protection, and laser classifications. While those are certainly important, true semiconductor laser safety goes much deeper than basic compliance requirements. As semiconductor equipment becomes more advanced and integrated, manufacturers need to evaluate not only direct beam exposure, but also contamination risks, maintenance hazards, industrial hygiene concerns, and long-term operational safety. In this video, we will look at some of the most overlooked areas of semiconductor laser safety and why manufacturers should approach these systems with a broader risk management strategy. Laser systems are becoming increasingly common throughout semiconductor manufacturing equipment. Low-power lasers are frequently used for gauging, alignment, measurements, and detection systems. Higher-powered laser systems may be used for cutting, annealing, marking, engraving, or ablation processes. As these systems become integrated into larger automated manufacturing environments, the safety considerations become more complex. This is especially important because multiple groups may interact with the equipment throughout its life cycle, including operators, maintenance technicians, service engineers, and R&D personnel. Each interaction can create different exposure conditions and different risks. One of the most important concepts in semiconductor laser safety is understanding the difference between primary hazards and secondary hazards. Primary hazards are the direct effects of laser exposure. These may include eye injuries, retinal damage, skin burns, UV exposure, and fire hazards. The severity depends on factors like wavelength, beam power, exposure duration, and whether the laser is visible or invisible. However, secondary hazards are often where larger operational risks begin to occur. Secondary hazards include electrical shock, heated surfaces, smoke generation, airborne particles, toxic material exposure, contamination risks, and UV degradation of insulation materials. In semiconductor manufacturing environments, contamination control is already extremely important. Laser-generated smoke or airborne particles can impact product yield, equipment reliability, and clean room integrity if not properly managed. This is why laser safety should not be treated as a standalone issue. It must be integrated into the broader equipment and facility safety strategy. Another area that is frequently underestimated is maintenance exposure. Many laser systems are relatively safe during normal operation because they rely on protective housings and interlocks. However, during servicing or troubleshooting, those protections may be bypassed or removed. This can expose technicians to direct beam access, energized electrical systems, thermal hazards, and smoke and particle exposure. In many cases, maintenance personnel actually face greater exposure risks than normal operators. This is why manufacturers should evaluate laser safety across the entire equipment lifecycle, not just during production operation. Laser classification is an important part of the safety evaluation, but classification alone does not guarantee safe implementation. Laser output characteristics may change if optical systems are modified, beam paths are adjusted, power supplies are altered, or the laser is integrated into a larger system. Because of this, manufacturers should evaluate laser systems at maximum operating conditions whenever possible. System-level integration can unintentionally create exposure conditions that are not originally anticipated. The strongest semiconductor laser safety programs rely on multiple layers of protection working together. This includes protective housing, interlocks, warning labels, administrative procedures, maintenance controls, personnel training, industrial hygiene evaluations, and medical surveillance programs. No single safeguard should ever be treated as the only line of defense. Strong safety programs also require coordination between engineering teams, EHS personnel, service teams, and facility operations. When these groups work together early in the design process, manufacturers are often able to reduce redesigns, improve serviceability, and support smoother evaluations later. Semiconductor laser safety is about much more than compliance checklists. The most effective safety strategies evaluate the entire operating environment surrounding the laser system, including contamination risks, maintenance access, personnel exposure, and long-term operational reliability. At HTDS, we help manufacturers evaluate semiconductor equipment from both a compliance and practical engineering perspective to support laser equipment and smoother paths to market. If your team is preparing for a semiconductor equipment safety evaluation, visit our website to learn more about our process and how HTDS can support your project. If you liked this video, please leave a like and subscribe to our channel for more information on semiconductor compliance. Thank you for watching.